This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
At Collide, we know end users are IT admins' most significant untapped resources and key to solving the most challenging to fix security issues, including instructing developers to set passphrases on unencrypted SSH keys, finding plain text two-factor backup codes and teaching end users how to store them securely, convincing employees to uninstall evil browser extensions that may sell their browser history. Visit collide.com/SERadio to sign up today. That's KOLIDE.com/SERadio. Enter your email when prompted to receive your free Collide gift bundle after trial activation. You can try Collide with all its features on an unlimited number of devices for free for 14 days. No credit card required. Try it out at collide.com/SERadio.
Welcome to Software Engineering Radio. I'm Akshay Manchale. My guest today is Vaughn Vernon, and we'll be talking about his most recent book, Strategic Monoliths and Microservices. Vaughn is an entrepreneur, developer, and software architect with more than 35 years of experience. He's a leading expert on domain-driven design, reactive programming, event-driven architecture, and he consults and trains people all over the world in his areas of expertise. Vaughn was previously here on SE Radio to talk about reactive programming with Actor Model in episode 49. Vaughn, welcome back to the show.
Thank you very much, and thanks for having me.
So let's jump right into the book. What is the key motivation behind it? And briefly, what is the message that you're trying to get across to the reader?
Yeah, so my experience is, like you said, more than 3 decades, probably approaching 4 decades. And what I've seen over the years is that there are some very good teams that work well together with executive management, with thought leaders and visionaries and so forth. And there are other teams who seem to be completely separated from that kind of active engagement with business vision. And when I have seen and worked in those environments with a strong relationship between business and technology, I generally see very good results. And so my motivation is in trying to surface this knowledge and to kind of set a bar for people to achieve within strategic initiatives, innovation, and to use examples from around at least the technology industries to basically motivate people that they can succeed in the same ways and use some of the techniques and, whether it's engineering techniques or innovation through discovery-based learning, experimentation, and things like that, and try to make others aware of it. And I think what's really unique about the book is that we are addressing C-level executives, senior VPs, chief architects, directors, and so forth, just as equally as we are solution architects, enterprise architects, programmers, and so forth, aspiring architects, because there's just a big lack in this kind of formulation between the business and technology, and I think that it has a chance to help a lot of companies.
So what is this general disconnect that you see between, say, business and technology, or business and how they actually run the business? And how does that actually lead to problems or missed opportunities?
Working in domain-driven design for a number of years and really having a pretty international exposure to clients for the past 10 years or so, what I find is that software developers like to complain about the business. Not that they like to, but basically they say, we can't engage with the business because they're unavailable. We don't know who the domain experts are. They won't talk to us. They won't whatever. And in reality, what I see is, like in a workshop, I will become the domain expert, right? In a set of scenarios where we're, in essence, working for a fictitious startup and we're trying to innovate together. And the exercises that we go through really lend themselves to interfacing with the business. And when I walk around to different teams and I suggest or even ask, do you need my help as the domain expert, co-founder of the company, right? Do you need help? Anything that I could clarify, anything in the business vision and so forth. And inevitably the developers will say, no, we got this. And that's a huge problem. I mean, they are there to learn DDD. And one of the basic premises of DDD is that you're going to engage with the business. And I don't know, why is it that message doesn't go all the way to the top floor, with these developers? I mean, before we do a single exercise, I'm already telling them that they have to do this and they don't. And okay, maybe that's sort of a learned behavior, a survival instinct or something like that. But they're given every opportunity to work with someone, myself, who represents the business and has their every success in mind and heart, and they still hesitate. Now, on the other hand, I do know that business people very often just get frustrated with engineers, technologists, and so forth, because the engineers always want to kind of talk down to them, condescend with big technical terminology, and there's always this translation between what the business says and what that means to engineering, instead of finding a common ground. So there's a lot of problem with that, a lot of frustration between business and technology engineering. And I think that a lot of that, since there is so much, someone just needs to bring this up to high enough level where people are forced to see it, right? And then we give suggestions in the book to, as we do when we consult and train, how to overcome these kinds of challenges. And so hopefully by making a sort of first-class concern, then others are going to say, yeah, we do absolutely have that problem, and it's necessary for us to do something about it.
In general, if you're coming from engineering or even from the business, you normally anticipate some amount of change to your underlying technology to support the business. So you said, communication is one of those barriers towards change, but are there other barriers that you see that prohibit change or results in change in a suboptimal way that results in what you call mud systems in the book?
It may sound strange. Maybe it doesn't. But I find that when I walk into a client, not all, but enough, and some of the clients that I engage with, you would be maybe surprised just about them, how much kind of fiefdom there is around certain areas of the technology and chief architects, for example. And these are companies who have multiple chief architects, right, and in different divisions and so forth. And they will be very resistant to change. First of all, they think that they don't have any problems, but the technical leadership has already identified problems, but they highly resist any change whatsoever, because then they sort of have to admit that they were wrong. But I don't think that there's much value in viewing it that way. Okay, everybody's wrong a lot of times in software. So we have to view this as an opportunity to course correct and make things better. So I don't know why people view it like that their job is in danger or something because they have to, renew something that's 20 or 25 years old, instead of just continuing to build on it and cause more atrophy and so forth. And that they just need to sort of, step up, say, yeah, you're right, we need to do this. In fact, what I've actually seen is that those who resist the kind of forward thinking, let's change things, senior, executive leadership, technical leadership will actually say, well, you actually may not have a future with this company if you're not willing to make a change. So they kind of think that they're preventing a bad path, but they're actually causing one by resisting. So that's just, that's the resistance to change. But then once you get to the point where people say, yeah, we have to change, a lot of what I see is that people expect that this is just going to disappear. All the problems that they have are going to disappear within a few months. I mean, even talking about a year from now, a lot of them will think, whoa, why would it take so long? Well, look, it's taken you years, decades, maybe a score or two of years to get where you are. You're not going to just jump out of that crystal clean, for within a few months. So there's just a lot of reasons for this. And in general, a lot of times the skill level of developers is really not very good, and they get a little bit jaded, I guess, or just demotivated from the fact that they haven't previously been able to really make a significant change. So this will just kind of put them into a let's collect a paycheck zone.
And I think on the other hand, you also have the tendency to maybe adapt changes that may not be necessary. And I think parts of the book kind of address that in terms of going after something that's new and shiny, for example. And so let me ask you this. Do you think monoliths are bad, or as opposed to, say, microservices? Are they good? What do you have to say about that?
Yeah. And just before I answer the specific question, yes, many very bright technology people are really chasing new technologies, bright, shiny, whatever. But my idea, and that I've, confirmed by others, experts that I've spoken with, they say that engineers have to be challenged. And if they're not challenged with the business problem, they're going to challenge themselves with technical problems to solve, right? Technical challenges. And so that will lead many to, want to use technologies in places where they don't really need them. But hey, we can, maybe it's open source. A lot of things are open source. Let's just use it. Doesn't really cost the company much, although it does in the end. So to address your specific questions, though, about are monoliths bad, are microservices good, probably for the past 7 years, I'm going to say at least, the word monolith has just gotten a really bad, reputation. And I don't think that it's really fair, but I think what people generally mean when they say the word monolith is big ball of mud monolith, right? The legacy system that is just out of sorts, has been subject to expedient changes for week after week, month after month, year after year. And the architecture, if there ever was really a purposeful architecture, has long disappeared or blended into this muddy kind of situation. And so this is really where the term monolith has become synonymous with bad software. But a monolith itself is not bad. In fact, probably most companies should be using monolithic architecture rather than microservices. Any given company can use both, make good uses of them. But, to address the second part of that question, or the second question, are microservices good? They can be, but, the microservice itself is not going to solve your problems, no more than bringing Kubernetes into your enterprise is going to solve your problems, or Kafka, right? I mean, these are just tools, and they're very, cool. They serve, a very excellent set of, a purpose with excellent qualities about them. But those things in themselves are not going to really solve many problems. So microservices are the same way. And in fact, microservices can end up causing more problems than they solve. And that is generally the case when a microservice is seen as a specific size, as in like lines of code. There's been, I would say, probably a lot more emphasis on the 100 line of code microservice. This is what makes a good microservice. And I'm not sure why that ever came up, because first of all, depending on the programming language, the number of lines of code could be vastly different for the same amount of behavior, of solution being offered. The other thing is that so if I have a microservice that's 150 lines of code, does that make it bad? Others say, 400 lines of code. I've heard that. I've heard 1,000 lines of code. The thing is, those are all just very, subjective. Like, then, what am I targeting these numbers? And instead of using those kinds of measurements, if you will, we suggest using domain-driven design as the first step in identifying a microservice and using DDD bounded context as the means to do that. And what we basically emphasize is determine what your ubiquitous language is within a bounded context. And that is, by modeling that becomes the size of your microservice, which is, who cares if it's 1,000 lines or 2,000 lines or 300 lines or 100, right? It's whatever it needs to be to express that ubiquitous language as a model. So if you kind of target that, it's a great place to start. And then you're not using any of these arbitrary size determinations and shooting for targets that have no real practical meaning. And I think it helps a lot. So yeah, anything in software has trade-offs. Microservices can be good, but they introduce a set of challenges as well. Monoliths can be good, but they also introduce a set of trade-offs, challenges with them. So we always have to look at what problem are we trying to solve? What solution do we need to come up with? And so let's have a purposeful architecture based on that and the configuration of our team and the rate of change in certain areas of the software. And maybe a monolith will work out in a lot of cases, or maybe a lot of the solution is in a monolith and we break out a few microservices because of the rate of change. And I also want to just caution people, I've heard this a lot about, if you want to increase performance and scalability and, a lot of, these quality attributes, right? So you're introducing these quality attributes. Actually, performance is not a good idea to have in mind if you're going with microservices, right? Because you introduce the network in there, that's going to greatly reduce performance. Okay, we are using the cloud a lot. We are doing distributed computing a lot. But if you really don't have to, there's no sense in introducing the network. And besides the fact that it's not just performance, but actually, okay, maybe you are looking for scale, but on the other hand, you introduce a higher probability of failure, right? Network partitions, just whatever, indeterminism in message receiving and things like that. So, everything comes with a set of trade-offs, and you just have to choose the positive trade-offs that fit your needs, and they should outweigh the negative trade-offs. And that's generally purposeful architecture. But the main emphasis is strategic innovation, right?
And when it comes to this sort of decisions about, say, spinning off something into a microservice, breaking it down, in the book you mentioned something called Conway's Law that influences interface design. So can you describe that and how that actually influences change, how that influences architecture over time?
So basically what Mel Conway said is, in this nutshell, is that software or any system that is designed is constrained to reflect or have a representation of the communication structure of the organization that created it. And that doesn't mean necessarily the whole big organization. Like if you're a Fortune 10 company, it doesn't mean that entire Fortune 10 company has an impact necessarily directly on one system that's somewhere, in that large organization. But the direct organization that is used to develop that will have their communication structure, will be reflected in that system design. Now, one thing that some people will sort of very kind of trivially, almost naively say is, well, what Conway's Law says is if you decide to use 3 teams to develop a system, then there will be 3 subsystems. And I think that's a gross oversimplification. And in fact, it's not even true, especially when you're developing with a microservices mindset. I mean, any given team could own multiple bounded contexts. And, so I just kind of throw that part of the understanding, I just throw it out the window. It's not worth considering to me. But what it really is saying is for whatever teams you put together, those teams must communicate really well in order for their design to reflect, well on their communication, because it will, right? It'll either reflect good communication or poor communication. And Mel Conway also, way back then, said, okay, so since most systems don't have the best design after the first, say, initial iterations, the first version, if you will, of the system, then organizations should be flexible and be willing to basically reorganize teams to improve the communication in order to improve the subsystems within the system, right? So I appreciate that some companies have come up with kind of catchy names for this kind of, maneuver, as it's referred to. But Mel Conway gave us those answers so long ago, right? Whatever, now 54 years ago. So it's pretty amazing that he had not only recognized the problem, but held the solution. And now, 50 years later, companies are just saying, yeah, well, this is how you should do this and this should do that. And it's just basically what he said so long ago. And yeah, it's really important, very, very important. And of course, domain-driven design is really chiefly about communication and learning, right? It's about discovering, experimentation, and this is how we learn and how we learn quickly. So the better we communicate, the quicker we learn, the better our systems will be, the less expensive they will be. So there's a lot of benefits to recognizing Conway's law and then setting our teams up for the best possible opportunity to succeed within that.
So you mentioned bounded contexts, and I want to get to that. But given what you just said, if I'm, say, a software architect or I'm some sort of a technology leader, how do you approach a particular problem by modeling this sort of like communications between people? How do you go about modeling the existing structures of an organization along with the technology that exists today in order to support, whatever incoming change requests are coming into you?
How do we solve problems with bounded contexts? One of the first things that a large organization can do, and again, limit the area to the problem space where you have identified we need to solve this scientific, innovation problem, and this will be strategically beneficial to us. What systems do we need to use? Let's take an inventory of what exists and what we wish was there or what we need to have that is missing, so kind of the gaps. And you can use business capabilities, right? You can kind of look for business capabilities that that you have and look for the areas of software that provide those business capabilities. In a very large enterprise with a number of legacy systems, those capabilities are very likely not necessarily even constrained to a single big ball of mud monolith. They could be kind of spread around, right? Like, okay, we integrate, just think of shipping, for example. How does shipping happen from an e-commerce perspective? I know this is not necessarily an insurance problem, but it just comes to mind. Where is your shipping logic in, your shipping model in a legacy system? It's probably in 5 different places at least, but you can still look at those 5 places as one context or one subdomain. And this helps you to sort of reason about the problem, even though it's not one thing, it's not one convenient place to go. You can still create that kind of illusion, and that might give you even a hint toward, maybe we want it. Maybe we want even in real software to make that look as if those 5 places are one place. So maybe that's a new service that just provides some kind of integration for us, right? And there are different ways to do that. But then we may have some well-designed services and systems, and those might represent in themselves bounded context. But the real sort of definition of a bounded context is a sphere of knowledge and a place where a model and a language, a human language that is spoken and understood by a team, and a relatively small team of individuals where they are innovating, this is a place where we are going to design and implement our software in this kind of contextual boundary, right? So think of if you have a a yard with a fence and your neighbors have yards with fences. Think of each of those as a different context, right? You all have maybe grass growing inside your yard, inside your fence. But what does grass mean to your family? Is it a place where your kids roll around and play, or is it a place where, someone in the family just loves to manicure the lawn and don't ever step on that, right? And so you can think of those as different contexts, even though they all have grass, maybe even very similar kinds of grass, but the context of the use of that yard and the purpose of that yard, why it exists, is different. So think of various areas of the business where you use the same words, right? Like policy. We use policy all over the place in an insurance company, but what does policy mean here versus what a policy means over there, right? And even though they may share some data between them and even share some terminology between them, they're generally speaking going to have different meanings. And so domain-driven design uses the bounded context to emphasize that we don't have to agree on the definitions of things, right, of the areas of software, and especially in specific models, right? We don't have to agree. Therefore, we're going to recognize those differences and bound them in a context where we can have a very, certain understanding of what those meanings are and what are the purposes, what are the business rules around it.
So it encapsulates all of that knowledge essentially in a way that you can then use to see how much can be reused, where it fits, how it can change, etc. Is that one way of actually using it?
Absolutely, yes. That is the idea.
Starting from this sort of like bounded context, I think you also talk about spheres of knowledge at various levels. Like, for example, if you have to go back to the example of yards and how you want to model that, the scope of where that utility of, say, your garden ends is something that you talk in the book in terms of actually modeling that in order to figure out, how things should actually fit in. So can you elaborate about how you speak about spheres of knowledge, the scope of it, and how that influences your design, or how that should influence your design, rather?
So sphere of knowledge actually is one of the 4 or so numbered definitions of the word domain, if you look in Merriam-Webster's dictionary. So if you look there under the word domain, there are like 4 primary definitions, and I think the third one is a sphere of knowledge. And domain can mean like a kingdom kind of domain or a governmental domain, and ownership of property and things like that. And in a sense, you can see some overlap in that. But the first primary definition that we use for domain-driven design is this sphere of knowledge, right? This is a place where a specific area of expertise exists. And the people that we have to have conversations with, or, including us, right? So everybody who has this kind of either business expertise in this area or software expertise in order to implement this properly and be a good listener and be a good collaborator and communicator, we are creating a sphere of knowledge. And the longer that we work together and the more valuable conversations we have, the more we learn. And so while an event storming may start out being like a really big picture across multiple subsystems or pre-existing systems that we will use to create this new innovative area, when we boil it down to that sphere of knowledge, then our event storming and our scenarios that we discuss and any kinds of conversations that we have, whether it's in written documents or just spoken words in a meeting, which probably are the most frequent, and then we actually take these ideas from our minds and we communicate them with each other, and we finally have this sort of shared understanding, then we can write tests and software and then make our software adhere to those tests and work, to succeed, to test green, in other words. Well, that is all part of the sphere of knowledge. So that is a context, right? And actually, to make a further point, generally speaking, that sphere of knowledge is also a subdomain in the entire problem domain, right? So now, when we're looking just at the areas of the enterprise or whatever you like to call it, right? That will contribute to the success of this innovation. Those various areas that we will work with and include in this initiative are all in some way or another separate subdomains, right? Or at least contribute to the separate subdomains. And so you can look at this landscape as being like, okay, this is our whole world right now. This is kind of our, whole world, this problem domain. And within that problem domain, we have subdomains, and some of those subdomains will be core, right? They will be places where we're really innovating and, in essence, making a big impact on the industry that we're working in.
I want to switch gears a little bit into transformation of software. So in your book, you talk about purposeful architecture and ways to transform monoliths into microservices or starting to build microservices correctly. So I want to switch gears to that. Let's first start with the monoliths, right? So how do you build monoliths correctly? Or what would influence you to say monolith is the right design when you're starting from nothing? And what would be the right way to actually approach that problem?
Our recommendation is actually to start with monoliths. So it's actually not even that you're starting with a monolith like that you're necessarily even planning to use a monolith long term, but by eliminating the network in most of the integrations within this solution that you're creating with new software, right? So we're talking about new software. Then you would use major modules within the monolith to separate the different bounded contexts. So think of a monolith that has maybe like 7 major modules. And we, in essence, treat those modules as if they are in separate services on the network, but they're not, right? But in other words, that's how much kind of like very definite separation that we have between them. And so our motivation in doing that is to make certain that we are not creating dependencies across bounded contexts, like strong coupling that would be very difficult to break later if we decided to sort of carve out one of those bounded contexts or a few of them and turn them into separate microservices. So there are reasons to do that. And I mentioned that before. One of the best reasons is rate of change, right? Is this context changing more often than the other 6 that are in this monolith? So that's a big part of it. But yeah, using modularity. And I've heard some interesting feedback on this. In fact, I've had some discussions about it, and some people think that if you're starting out with a monolith, you will certainly not want to create multiple bounded contexts within there, but you'll just want everything to just sort of allow it to be jumbled up. And I truly cannot understand why that would be a purposeful initiative, because it's the very thing that we're trying to avoid is the big ball of mud. And you're just absolutely doing that is moving quickly in the direction of a big ball of mud if you just say that we're limiting our discipline in the modularity for contextual separation. It doesn't mean that we have to introduce heavyweight, for example, messaging systems. There are several lightweight messaging systems that we can use between, to communicate between the bounded contexts, or we can even use, in essence, what would be similar to REST or so, but it doesn't have to be REST. I mean, it can be REST from an API perspective of using, post, get, put, delete kind of thing, but it doesn't have to be over HTTP, right? It doesn't have to be over TCP on the network. It can just be method invocations, but they're loosely coupled, and they might even use multi-threading just to keep things very separated. And Well, now we're getting into another area of reactive, but that is basically the motivation of a modularized monolith. Now, again, we're not even making a decision yet if we should use any microservices at all, or if all of those modules should be turned into microservices. But what we're doing is we're saying we want to innovate first. We want to have, high iterative and incremental value deliveries in these multiple bounded contexts. And we're purposely leaving out the network right now. In fact, you might even just use in-memory databases and so forth. You don't, this is where we're just trying to get the model right, where we're trying to understand, okay, solve the business problem first. Because when you take it the other way around and you say, okay, hey, we're going to start doing microservices. Tell you what, you spin up, something on Azure and I'll spin up something on Google Cloud Platform and you do something on AWS because, hey, we need multi-cloud, right? And oh my goodness, right? I mean, anybody listening to that should just say, anybody that's starting out a project in that way just seems really immature to me. It's just the wrong time to introduce things like that. So introduce those things later when you know that they're absolutely necessary, but get the business innovation first.
I think in what you're saying is when you're trying to model it at that level, you're also disconnected from the specifics of implementation choices, right? Like where this is going to run or what language I'm going to write this in. You're really exploring what the interfaces should be between your bounded contexts. Or are you also saying that you should go a little bit deeper?
Well, I mean, you go deeper as you learn more, but for example, some people will just say, well, let's introduce a NoSQL database, But I don't is that the right thing to do right now? How do you know that, right? So first of all, just create, if you think a NoSQL database works, then create a simple, interface for a NoSQL database, which is basically a hash map or a hash table underneath, and just see how that works, right? But if you find later, oh, look, well, it's really hard to query that. It doesn't support the kinds of queries we'd like. Well, what should we do about that? Should we introduce CQRS or, well, that, it seems like a little bit of overhead here. We don't really need that kind of thing, but maybe just a relational database in this case would work better for us, right? It would just be simpler. And maybe this is some supporting software that isn't even core, for example. And we just decide to say, let's not burn too much cash on those kinds of expenses, right? And let's just keep it really simple. And hey, for the scale and the performance that we have, 10,000 transactions per second is way more than we need. And I'm just speaking for sort of like the 95% or so of all software projects. Of course, there's that 5 or maybe even just 1% of software that needs, those off the charts kinds of scale and throughput. But I'm just talking about for most, right? 10,000 transactions per second that you can get from quite easily, in fact, from Postgres and especially on the cloud, right? Then just avoid those kind of really heavyweight decisions at first, or things that will just complicate the overall solution.
But I mean, even if you have that sort of need where you need 100,000 transactions per second, I feel like that might be its own bounded context that provides that layer, that provides that service that others should be consuming. Or do you think that even there, it's just simply not necessary for you to go down that path of exploring, what might fit the performance or scalability needs?
I don't generally think of a bounded context in a very technical way. In other words, should a bounded context be primarily for persistence? There are some ways of using bounded context for a sort of messaging switch or router, but those have additional purposes. But I wouldn't think of having a separate bounded context that would just provide persistence.
So what about existing software? You might have an existing monolith that maybe it's not completely unmaintainable, maybe it has some modules, but how do you go about trying to prepare that into a microservice? Why would you do that one? And how do you actually go about breaking it down so that you can separate things out while also supporting the monolith along the way?
Well, assuming that we have started with a well-modularized monolith, right? So we're developing a new system, and we have, like I said, just as an example, we have 7 different bounded contexts in a monolith. When those separations are very clean between the 7, then taking one out of that monolith and turning it into its own separate deployment unit and introducing the network is pretty straightforward. I mean, you will have to introduce the network. You will have to decide things like, well, okay, are we going to communicate with REST to this other context, or will we use asynchronous messaging or, a messaging mechanism, whatever it happens to be, the network will be involved. But you've already got those, what we would call in a ports and adapters architecture, you've already got those adapters figured out. You just need to change the technology that's underneath them. And if you design them correctly, there won't be, leaky abstractions.
I guess if you have the clear boundaries, you could always just take that apart and then use the same interface over, say, the network. But what if you don't, right? Everything is a entangled mess. And is it always better to just throw away everything and start from scratch? Or is there like a generally good way where you can go in a purposeful way where you know what you want as a microservice, what you want to remain in the monolith, and actually find a path to unentangling that mess of your software?
Just for example, yes, there are ways to take a big ball of mud monolith and redesign/refactor that. And we provide several different approaches for different tools and patterns and so forth for doing that. And, it doesn't happen overnight, and there's going to be a lot of work to it. And generally speaking, it means introducing unit tests where there never were unit tests before. And, so it can be a lot of work. Now, the total throwaway, not that you completely throw away, but just think of these, many, many financial services companies, whether they're banks or insurance companies or whatever they happen to be, and they are just, laden with COBOL. I mean, no disrespect, but there are a lot of organizations that we work with that are just very burdened with these 40, 50-year-old systems that are running on mainframes with COBOL, and it's getting very difficult to find developers. It's not news to anyone with experience in that. But so they're not throwaway. You do have to probably mine a number of, not probably, you have to mine a number of business rules out of their calculations, whatever those kinds of heavy lifting things. But one advantage is that sometimes those COBOL systems are so old that a large number of the business rules are now obsolete, right? Had one company that I think they identified something like 75 or 80% of all business rules since the mid-1970s no longer had any relevance. So now can you imagine not studying that and understanding, and you actually go to the effort to sort of port out all of those business rules, calculations, and whatever, and then a few months after you've done that, someone says, we don't even use that anymore, right? That as in like 100,000 lines of code or more, or millions. So, yeah. So it's not easy, but definitely you're looking to do full system replacement for those kinds of situations. But if you have like even, like a legacy Java system or a legacy Ruby on Rails system or .NET or something like that, and there are plenty of those, it sounds funny because I was still relatively young when these technologies came to existence, and it's sort of funny to think of Java having legacy systems, but then you remember, oh yeah, I've been using Java for like more than 20 years now. So yeah, there are plenty of legacy systems there. But the fact that you can reshape those with a lot of effort, yeah, you can salvage some things out of there, but it's mostly going to be kind of restructuring, as in finding new modules and trying to bring the cohesive classes, if you will, or objects together into one area and call that a bounded context now, right? That's what you're trying to achieve. And you typically have to do that sort of like one context at a time. Or even if you're doing many at once, you're sort of doing it piecemeal. And as you're making changes anyway that are driven by, like the business says this has to change, or we have a bug that we need to fix in here, you can use that opportunity to go in and start cleaning up that area. So while you're there, why not write some tests? Why not look for a new module for that and put it with the other cohesive parts of that language? And now you're kind of slowly creating at least modularity, if not bounded context within there.
Okay, that's great about existing software, but let's say you're trying to start something new, but you want to build microservices, maybe because you have lots of people, lots of very clear responsibilities and roles where things are separated. So maybe it just looks like a microservices architecture would be better. And if so, how do you approach that problem? How do you approach modeling your problem space so that you build microservices in a way that does not introduce extreme complexity, but also allows you to change in the future?
There's really determined, purposeful effort being put into this. So when you know that you're going to develop microservices and you know that this is happening as a core effort, then how do you do that well? And as we said before, or as I said before, and as we say in the book, look for capabilities, look for bounded contexts, and bounded contexts are going to be in the areas of expertise of spheres of knowledge, right? So this is where you have to talk to certain business people to understand the rules and the mental model that they have and how to formulate a software model from this. And this is a great place to start for microservices. But again, if you develop the well-modularized monolith, we also show in that 11th chapter how to go from a well-modularized monolith to microservices. So, both of those, though, are using bounded context as the driver. And again, just going back to what a bounded context is, a sphere of knowledge, a place where a team has conversation, directed conversation, purposeful experimentation, and looking, to learn and learn rapidly. This is a bounded context. And when a microservice is deployed, or I should say, maybe that when a bounded context is deployed as a microservice, then that is a very reasonable goal to have and will very often work out well. Now, the opposite of that is, like a microservice that only, for example, it just creates a new entity of a certain type. Then you have another microservice that updates an entity of the same type that you have a microservice to create, right? I mean, this is the sort of granularity where I'm saying danger zone, that you really don't want to be down in those weeds from the beginning, for sure. And hopefully you won't end up there even in the end. So you may need to take certain components, maybe entity types, or in DDD, maybe what we would refer to as an aggregate. And some of those you may need to break out because the business rules around those change more often. And it might make sense to just isolate those areas of change so that you can deploy quickly, right? And you don't get sort of the other parts of the same context don't get in your critical path and in your way of quicker delivery. But still, they are part of the same bounded context, right? Logically speaking, the purpose of this is to maintain this sphere of knowledge, and the team stays together, even though now they have multiple units of software components to deploy.
I do think that sometimes if you're that isolated, maybe you could end up doing something some other team is doing. Does this lead to some sort of siloing when you say you want to actually create this sphere of knowledge, this bounded context, and then they go and build what they're building? But does that lead to siloing? Does that lead to repetition of something someone else is doing? Maybe it does, and how do you break that?
Well, in some organizations, you may never know if that happens, literally, right? I mean, it's one thing to know that it happens. It's a completely other thing to be like completely oblivious to the fact that, that other 100,000 person, part of the organization did this very similar to us, and we could have reused it, but we didn't even know that it existed, and they don't know that we exist. But one thing to remember is that don't repeat yourself, or the DRY principle, right, is about knowledge. So don't repeat yourself means don't repeat the same knowledge around a system. It doesn't mean that code cannot be repeated. I know that may sound like sort of a contradiction, but it's really not, because maybe the code that exists in multiple places is just like we have the same attributes or properties on a class, right, on an object. But we're careful not to leak knowledge across bounded contexts. So this is where, again, you may have something named policy in 2 or 3 different places or 5 different places. And that policy they'll all have a policy ID, and this will all go, all those IDs point back to sort of that system of record where the policy first existed. And maybe some of the attributes are, like, what's the type of policy, or what is, these kinds of sharing of things. But that is not knowledge that's being repeated. That's just data and, necessary repetition that we're using. So first of all, if we are not repeating knowledge, then there isn't really a don't repeat yourself. Another principle to use, though, is just simply that DRY is a context to context concern. So even if you have to repeat some things in another bounded context, do so without making a real silo. And this is sort of the pattern or the context mapping approach that's known as separate ways. It's like, okay, we could integrate, but the payoff for this integration, the complexity versus the gain that we will get from it just isn't worth it. So we're going to go separate ways. And this is where, we may repeat something, but we are really certain that and make concerted effort not to create silos in that case.
So if you don't repeat the knowledge, then I guess in some sense, the underlying business problem is not solved in 2 different places by repetition. So you don't really drift across what should really happen for the business.
Yeah, one way to think about that is, for example, when calculating risks. So let's say that we have a bounded context around calculating risk, and we have another bounded context for calculating rate, as in what is the premium that will be paid, for example, for this automobile insurance. Well, we don't want the rate system or the risk system leaking into the rate system, and we don't want the money kinds of things falling back into the risk system. So that's where you would have a definite like repeating of knowledge. So, but you will still be talking about you'll still be working on the same policy. Well, it's at that point it's an application, right? So someone has applied for insurance. So you'll still be looking at the same pieces of data, but for example, when you calculate the risk, that risk will be passed on along with the application to the rate calculator in that case. So yeah, you definitely want to keep those 2 things separate. But the fact that we have to reference the same properties in the application, and that we will use the rate calculation outcome, or the risk calculation outcome in rate, doesn't mean that we're repeating knowledge. It just means that we have to use that data and those attributes to accomplish what we need to do in calculating a rate.
One last question is, what stage do you make decisions about exactly what technology you use to actually build these? Let's say you do go down the microservices path, as we were just talking about. At what point do you say, these are the technology choices that we're going to make? Do you actually go for something that's more homogeneous, where every microservice is maybe written in the same language versus in different languages? Maybe they're completely independent. What are the trade-offs, and at what point do you make those decisions?
Well, that's a really cultural sort of decision to make. And I think that kind of decision, to me, it's sort of like, well, if you're Amazon, maybe you want to give complete autonomy to a team and say, if you want to use some sort of almost unknown language, like maybe you even wrote your own compiler. So I don't know what the rules are, but in other words, it could be to that extreme where people are just like way out on the razor's edge of something. And maybe to Amazon, it really doesn't matter because their services are so small that if someone comes along and goes like, oh, well, they left the company and nobody's here to support that compiler, let's rewrite it in blah, right? No big deal. But, if you're in, the startup company with, you're hiring your 70th employee, and you've already introduced 5 or 6 different languages across microservices, that sounds pretty risky to me. It just seems like, do you really want to create that kind of culture early? And what are the risks of, like if someone would leave, if an individual or two would leave, what's the probability of hiring someone in their place? But it's even really more than that. It's like, just choose the right language for the job. So there, like for example, Python, even though I think that, Python is quite an expensive language to use for runtime, right? It's not really a very efficient language. But if there are tons of machine learning type libraries for Python, well, you're just going to use Python for machine learning kinds of things, right? So, I mean, it makes sense. So even a startup with hiring their 70th employee just around the corner, they're going to use that. They're going to use Python. They're going to use, whatever, maybe Kotlin, maybe C#, F#, whatever. But sort of make sure that it's not a single engineer, kind of bus factor kind of problem that you could face. And as long as you have a number of individuals that have expertise in those languages, then it's really not a problem.
Yeah, that makes sense. And one last question to conclude. What do you think people at various levels should be doing to go towards purposeful architecture? Now, there's a lot of things that we've talked about that's mostly about, say, aimed at technical leaders, maybe even executives, but also individual contributors and regular software professionals. What do you think they can take away from this book in order to move towards, say, purposeful architecture in their day-to-day jobs?
Just completely shift gears to innovation as, software as a strategy, software for delivering innovation. And when your mind shifts to that and you're having fun solving difficult business problems, right? Like, then you don't need Kubernetes and who knows what, right? To be that sort of like feather in your cap, because you're just having too much fun, like doing heavy lifting for the business and really doing innovative things. Then the architecture that you choose will sort of fall in place, because you're already challenged enough with the business challenge and the business innovation that you don't want to in any way make your delivery any more complex, because hey, that's just going to take away from the fun of innovating, right? And I think that so many software developers are very, very capable of being, not necessarily great inventors, but great innovators. And there is a difference, right? Invention means something sort of from nothing, a very original idea. innovation means taking something that exists and making it much better. So, I think many software developers can offer that kind of high-class capabilities to a business, and that's going to make for a really great partnership between business and software developers.
Juan, it's been wonderful talking to you. Thanks for coming back again.
Thank you.
This is Akshay Manchale for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.